Start again. Okay. So properties of alkene. So alkenes undergo electrophilic addition reaction. Started, right? So why alkenes undergo electrophilic addition reactions? Because alkenes having carbon-carbon double bond. Due to presence of carbon-carbon double bond, they undergo addition reaction. And why they undergo electrophilic addition reaction? Because alkene itself acts as a nucleophile. So since alkene is a nucleophile and having carbon-carbon double bond, and it undergo nucleophilic addition reactions. Okay, in nucleophilic addition reaction, first one is, what is the first one? Addition of halogen, completed, no? Addition of halogen completed. Next, second one, addition of HX, is it finished? Completed. Next, third one, addition of water, has to start. Okay, right. Third one, addition of water in acidic medium. Okay, so this is we will study in alcohol topic. So alkenes reacts with water in acidic medium, they form corresponding alcohol. How? Okay, take the statement, alkenes reacts with H2O in acidic medium to form corresponding alcohols. So therefore alkene gives alcohol. Alkenes reacts with water in acidic medium to form the corresponding alcohol. For example, CH2 double bond CH2 plus H2O in acidic medium. Tell me, H2O produces H plus ion plus OH minus ion. Then add H plus to one carbon, OH minus to another carbon. Come on, tell me, if H plus is added to second carbon, OH should be added on first carbon. Then the product is CH3, CH2, OH, which is called alcohol. Which alcohol? Ethyl alcohol. So therefore it is a electrophilic addition reaction. Then tell me, since it is electrophilic addition reaction, we need to study mechanism. Tell me, in mechanism, what is the first step? Formation of electrophile. Let us take water, it undergo hydrolytic cleavage, it form H plus plus, OH minus. But in fact, this H plus ion concentration is equals to what? H3O plus concentration. Then step 1 is formation of electrophile. Step 2 is addition of electrophile or what? Addition of electrophile to alkene. Now there are two carbon 1, carbon 2. Both the carbons are same or different? Same. So since it is a symmetrical alkene, so this addition does not follows Markovnikov rule, is not required. Therefore you can add H plus to either first carbon or second carbon. Suppose H plus ion is added to second carbon, then what happened, tell me? Then CH2 becomes CH3 plus, then at the same time pi bond is shifted on second carbon, then where you get carbocation? First carbon, then it becomes CH3 CH2 plus. Now this is called plus E effect, and of course it is a RDS, rate determining step. Then in this reaction, carbocation is the intermediate. Now this carbocation may undergo rearrangement. So wherever carbocation forms, we need to check rearrangement. Tell me, is it undergo further rearrangement? Not, because it is a primary carbocation, and this is also primary carbon. So we'll get primary carbocation only. Next, step 3. This carbocation now reacts with nucleophile. What is a nucleophile here? OH minus. So OH minus is added here. Then the final product is CH3 CH2 OH. Okay, so therefore here important point is In this electrophilic addition reaction, carbocation formed as a intermediate. Then tell me, write 2-3 important characteristics. 1. What is the characteristics of this electrophilic addition reaction? It is a plus C effect. 2. What is the intermediate? Carbocation formed as a intermediate. It may undergo, of course, rearrangement. Okay, and it follows which rule? Markovnikov rule. So what Markovnikov rule says? Richer become rich. Okay, then write quickly product here. CH3 CH double bond CH2 H2O, it is acidic medium. Come on, write the product. Tell me. So in first example, it is according to Markovnikov rule, right? So according to Markovnikov rule, where the H plus added and where the OH minus should be added? H plus added on first carbon, OH on second carbon. So therefore the product is propane, which ol? 2 ol, according to Markovnikov rule. Richer become rich. Next, in this example, now where the H plus should be added? On first carbon. Then where you get carbocation? Second carbon. If the carbocation formed on second carbon, which is called secondary carbocation, then it undergo rearrangement. In rearrangement, what shift it is? 1, 2 hydride shift. Then where the OH is added? On this carbon, no? Will you write product? So therefore the final product is CH3 OH CH2 CH3. And tell me here, and tell me H plus and OH minus. You just tell me where the OH minus should be added. On tertiary carbon, no? This methyl shift here. Yes or no? Next, and tell me here, where the OH minus should be added on third carbon. So there is a hydride shift takes place here. Next, now where the OH minus should be added? Third carbon, 1, 2, 3. Then now what is the shift here? It is a methoxy, nitro, it just phenyl. So methoxy phenyl, right? Because magnitude of shift or migratory aptitude is directly proportional to electron density. Next, tell me, this is ring expansion, right? So same example we have studied. For example this. Let us take, it is a 5-membered ring, right? Tell me, add H plus and OH minus. So now let us add H plus. This is CH2, right? CH2. It is one hydrogen will be there. So therefore H plus added here. Then where you get positive charge? Pi bond shifted here. Then the positive charge is on secondary carbon, right? Okay. Tell me now. Important is, if it is a 5-membered ring and it is a carbocation. With respect to 5-membered ring, if the carbocation or positive charge present on alpha carbon, it must undergo ring expansion. 5-membered ring become 6-membered ring. So therefore, it is an ring expansion. So ring shifted here, here. Okay. So that the product is the another carbocation is 6-membered. In 6-membered ring, positive charge comes here, but it undergo further rearrangement. In another rearrangement, this hydride shift takes place here. Then carbocations comes here. The next is then OH minus attack on same tertiary carbocation. Tell me here. When according to Markovnikov not required here, but when you add H plus, you will get positive charge 1 carbon. But particularly if it is a 4-membered ring, 4-membered cyclic ring, positive charge is present on the cyclic ring, it undergo ring contraction. So on ring contraction, tell me, this sigma bond shifted here, then what do you get? It is called CPM, cyclopropyl methyl carbocation. It is extremely stable. The next is OH should be added here or no? Then product is this. Next here, according to Markovnikov not required, add H plus here, OH here. Here according to Markovnikov rule, OH here, H here. So it is a addition of water to alkene. So same reaction we are going to study in alcohol topic. It is actually preparation of alcohol, one of the method. Okay. Tell me. Huh? Inkodu. Huh? Which one? Which one? This? Now suppose if the H plus is added here, pi bond shifted here, no? Positive charge may come here, or else adunu barutte. If not, H plus add here, pi bond shifted here, positive comes here. When positive charge come here, now this bond, sigma bond is there now. This sigma bond is broken, it is shifted here, so that this become positive charge. Then attack of height. Okay, fine. Now this is a primary carbocation, no? Question is, no, there is a hydrogen is there. If the hydride shift takes place here, you will get tertiary carbocation. But CPM carbocation is more stable than tertiary, no? When carbocation present here, that is more stable, right? This carbocation itself is more stable compared to this. That's what, no further rearrangement. Even the tertiary comes, but not here. Okay, this is addition of water to alkene. Next, third one, this is third one, no? Fourth one, fourth one. Next, fifth one. Okay, now it is fifth one, no? Fourth one, okay. Addition of dilute H2SO4. Right, addition of dilute sulfuric acid exactly similar to addition of water. Okay, only difference is if it is alkene reacts with dilute sulfuric acid. Tell me, the meaning of dilute is there is a more water. So sulfuric acid produces H++, HSO4 minus. Now add H plus and HSO4 minus according to Markovnikov rule. So richer become rich. Anyhow here H plus is added to one carbon and anion added to another carbon. Then CH2 become CH3. This CH2 become CH2 HSO4 minus. This is intermediate. Now further it undergo hydrolysis because there is a dilute, no? Right. So dilute means there is a lot of more quantity of water will be there. There is a water. This water, in presence of water, it undergo further hydrolysis. In hydrolysis, H plus added here, OH added here. So therefore it become CH3 CH2 OH. Therefore addition of dilute sulfuric acid exactly similar to addition of water. So therefore product will be same. Now question is like this: H2 CH2 double bond CH2 1 dilute sulfuric acid to hydrolysis. What is the product? Add water according to Markovnikov rule. You just add the water according to Markovnikov rule, that will be the product. Same. Next, you just complete the reaction. CH3 CH double bond CH2, it is 1 dilute sulfuric acid to, there is a hydrolysis. Sometime even they do not mention water also. It is understood. Dilute means there is a water. So therefore you just write according to Markovnikov rule. Dilute sulfuric acid. It is according to Markovnikov rule. Carbocation will be formed. Everything is same. The product will be same as addition of water. Next, addition of HOCl. Tell me, next is fifth one, addition of HOX. What is HOX? Hypohalous acid. Like example HOCl. And tell me, this is already we have studied electrophilic addition reaction example. And tell me, in HOCl, Cl is a positive, OH is a negative. So therefore add according to Markovnikov rule. Now tell me, CH2 double bond CH2 plus HOCl, HO is a negative, Cl is a positive. Since it is a symmetric, correct, no? Since it is a symmetrical alkene, you can add H plus 2, that is OH minus to one carbon, Cl plus another carbon, it become CH2 OH CH2 Cl. Okay. Next, if it is unsymmetrical alkene, follows Which rule? Markovnikov rule. Now let us take HOBr, hypobromous acid. HOBr also similarly OH minus Br plus. So add according to Markovnikov rule. Tell me. Yeah, there is a possibility of HOCl may give H plus plus OCl. OCl should be minus or no? OCl minus. Is it possible? Tell me. Have written like this? In electrophilic addition reaction we have studied, no? Have you written like this? Okay, ionic OCl minus is possible, but now question is here whether in this reaction it is possible. I'm telling it is like this, no? Okay, here the bond breaking between oxygen hydrogen, oxygen chlorine. So this is require less energy, and this can be broken easily. Right, oxygen chlorine bond. Okay, this is a more polarized bond. It requires less energy to break, so that oxygen has more electronegativity compared to chlorine. It get negative, it get positive. ಅಲ್ಲ ಎಲ್ಲ ಬರಿಬೋದು, ಅದು ಬರಬೇಕಲ್ಲ. OH minus exist, of course. OCl minus exist, possible. But here, this is not possible. So here also same. ಎರಡು ಸೇಮಾ? HO ಇದು ಬರಿಬೋದಂತನಾ? ಬರಿಬಾರ್ದು. ಏನು ಬರಬಾರ್ದಂದರೆ ಇದು ಬರಬೇಕು ತಾನೇ? ನೋ, ಏನೇನ ಬರಿಬೋದು, ಅದು ಬರಬೇಕು ತಾನೆ. Right, this ion, I am not telling that ion does not exist. Ion exists, but this ion cannot be formed from this. ಇಲ್ಲಿಂದ ಬರಲ್ಲ ಅದು. ನೀವು ಬೇಕಾದರೆ ಸಾಲ್ಟ್ ಇದ್ದರೆ ಬರುತ್ತೆ, NaOCl ಇಲ್ಲಿಂದ ಬರುತ್ತೆ. That is okay, because here sodium is Na plus, it is a O minus, no, that is possible here. But from this compound, this is not possible. Okay, because of bond enthalpies. Okay, then tell me now, HOBr. So according to Markovnikov rule, you can write the product HOCl next, sixth one, addition of NOCl. What is NOCl? Nitrosyl chloride. Nitrosyl chloride. Like similar to HOCl, nitrosyl chloride also dissociate same. NO become NO minus, Cl become Cl plus. So therefore, it is also be added just like HOCl. Complete the reaction. Okay. Next is oxymercuration, demercuration, right? Seventh reaction is it is according to Markovnikov rule, no? According to Markovnikov rule, where the negative part of adding group should be added? Negative part of adding group should be added to the double bonded carbon having less number of hydrogen. That is actually Markovnikov rule. Okay, but we are telling that poorer become, that is richer become rich. This richer become rich is applicable when there is only H plus ion. If electrophile is H plus ion, then you can use richer become rich. If electrophile is other than H plus ion, negative part should be added to the double bonded carbon having least number of hydrogen. This is the statement of Markovnikov rule. Next, seventh one, mercuration, oxymercuration, demercuration. Oxymercuration, demercuration. Right. So what is oxymercuration, demercuration? See here, alkenes reacts with one mercuric acetate. The first reagent is mercuric acetate. Second reagent, in presence of water and tetrahydrofuran, THF, it is called tetrahydrofuran. It is a solvent. Water and in presence of tetrahydrofuran, and which is followed by sodium borohydride and NaOH. Sodium borohydride is one of the selective and strong reducing agent. Okay, then tell me, in presence of these three reagent, then alkene just convert into alcohol. Okay, alkene convert into alcohol. Then how this alkene convert into alcohol? This is also very simple. For example, if you take alkene which is reacts with mercuric acetate, in mercuric acetate which gives acetate ion and mercuric ion, acetate ion is added to one carbon and mercuric ion is added to another carbon. For example, CH2CH2, here if it is acetate ion is added, now this is linked with mercuric ion Hg. Now this is further reacts with water. Okay, it is further reacts with water. Water produces what? H plus and OH minus. So therefore H plus is added here and OH is added here, and this reaction takes place in presence of sodium borohydride. So therefore tell me, if it is, one second, H plus, here is, it is negative, this is positive, right? And tell me, if this bond is broken, what is added here? H plus, here it is OH minus, right? And this is, this is undergo reduction. Therefore what do you get? CH2OH, and CH2, that CH2 undergo reduction, it gives us to CS3. Therefore the final product is nothing but alcohol. Now here one important point, in this reaction alkene convert into alcohol. This is takes place according to Markovnikov rule, but no carbocation as intermediate. See, in the sequence of reaction, do you find any carbocation here? First is mercuric acid added, when mercuric acetate is added here, mercury and acetate, this is the one intermediate. This intermediate undergo further hydrolysis followed by reduction. In hydrolysis reduction, both takes place simultaneously. No carbocation will be formed. Carbocation does not formed, but this reaction takes place according to Markovnikov rule. So therefore, here writing product is important. Take one important note. This reaction takes place according to Markovnikov rule, but no carbocation formed as a intermediate. So this reaction takes place according to Markovnikov rule, but no carbocation form as a intermediate. So therefore, now tell me, writing product is important. First reagent, mercuric acetate. Second reagent, water, THF, tetrahydrofuran. Third reagent is reduction, sodium borohydride, and there is a alkali, sodium hydroxide. Come and tell me product. Alkene converts into alcohol. You convert alkene to alcohol, write the product which is according to Markovnikov rule. So what is the product according to Markovnikov rule? Secondary alcohol is formed. One more. If it is and tell me now, same reagent will be there. If there is a same reagent, now tell me where the OH should be added. OH should be added on first carbon or second carbon? First or second carbon? Tell me. Second carbon. Right? No carbocation, no rearrangement. But add according to Markovnikov rule. So therefore, OH comes on second carbon. That's it. You should not write rearrangement product. That's it. Okay, so these are the electrophilic addition reactions of alkene. Tell me, so what we have studied so far in electrophilic addition reaction? One, addition of halogen. Okay, X2. Addition of halogen. 2. Addition of HX. 3. Addition of water. Which medium? It must be acidic medium. 4. Addition of dilute sulfuric acid. See, addition of dilute sulfuric acid exactly similar to same. This is also same meaning, no? Addition of water, acidic medium. It is also addition of water, acidic medium. Both are same. Fifth one, addition of HOX. Sixth one, NOCl. Addition of NOCl. Seventh one, oxymercuration, demercuration. So in all these reactions takes place according to Markovnikov rule. Okay, then where the carbocation forms, where carbocation does not form. So carbocation does not form only in last reaction, 7th. In other reactions carbocation formed, but here in addition of halogen there is another point. Here carbocation does not form. Here cyclic halonium ion is formed. It's not carbocation, cyclic halonium ion formed, and this is a which addition? Anti-addition. Okay, so next is oxidation reactions. So alkenes can also undergo oxidation reactions. Now same oxidation reactions we have studied in alkane topic. Do you remember? Alkane can undergo which oxidation? 1. Complete oxidation. 2. Partial oxidation, incomplete. 3. Controlled oxidation. So therefore, in case of alkane, we have studied 3 types of oxidation. But here we have many. Compared to alkane, alkene undergo many type of reaction, particularly in oxidation also, there are many oxidation reactions. Okay, first one will be same. What is the first one? Complete oxidation. We know that all hydrocarbons, not only alkane, alkene, alkyne, even alcohol, aldehyde, ketones, all hydrocarbon, all organic compounds can undergo complete oxidation. There will be only 2 products, CO2 and water, and energy will be there, right? So therefore, like similar to other hydrocarbons, alkenes undergo 1 complete oxidation. This complete oxidation also called what? Combustion. Tell me, alkenes undergo complete oxidation or combustion. They form carbon dioxide and water. Okay. So therefore, alkenes undergo complete combustion. They form CO2 and water. Then for alkane, alkene, alkyne and benzene, means particularly hydrocarbons. For hydrocarbons, there is a common reaction or general equation. What is the general equation for combustion? CXHY plus X plus Y by 4 O2 gives rise to XCO2 plus Y by 2 H2O, where X equal to number of carbon atoms and Y equal to number of hydrogen atoms. Tell me, this formula applicable for what? Only hydrocarbons. Of course in benzene also, for benzene also. That means hydrocarbon must have only carbon and hydrogen. If other than carbon, hydrogen, if there is a nitrogen, oxygen, we cannot use this formula. We have another formulas. Different formulas are there. For hydrocarbon, alkane, alkene, alkyne, even benzene, this formula can be used because benzene also contains only carbon and hydrogen. Wherever carbon and hydrogen is present, this formula can be used for complete combustion. For example, let us take CH2 double bond CH2 ethene. Ethene also called ethylene. IUPAC name is ethene. Common name is ethylene. Ethylene gas. Okay. What is the use of ethylene gas? Yes, ripening of fruits. Okay. So therefore, ethylene undergo complete combustion. Tell me, how many oxygen should be taken? 2 carbon, 4 hydrogen. No. 2 carbon, 4 hydrogen. It becomes 3 oxygens gives rise to 2 CO2 plus Y equal to how much? Y4 no. 2 H2. Okay. It is complete oxidation. Next. Second one, very very important, hydroboration oxidation of alkene. This was the previous NEET question. Hydroboration oxidation of alkene. So what is hydroboration oxidation? Say for example, let us take alkene. Alkene reacts with diborane BH3. Actually diborane is B2H6. B2H6 contain 2 moieties, 2 BH3. Okay, so therefore here we can take one moiety or one part. Therefore, alkenes reacts with diborane BH3. So this BH3 produces BH2 plus H minus. Here important, not H plus, H minus, because it is a reducing agent. Diborane produces H minus, not H plus. It is not acidic nature, it is a reducing nature. Okay, then tell me, now add according to Markovnikov rule. Markovnikov rule is required here? Not required. So we can add H minus to one carbon, BH2 plus to another carbon. So therefore here BH2 plus I'll add on this carbon, first carbon, and H minus on second carbon. So therefore second carbon becomes CH3, first carbon becomes CH2, BH2. Yes or no? This is called alkyl borane. Alkyl borane means ethyl borane. Particularly you can write ethyl group, no? Ethyl borane. So can you tell me this ethyl borane reacts with another molecule of ethene, yes or no? It reacts with another molecule of or another mole of alkene. Why? This BH2 again dissociate how? BH is a plus, H is minus. Therefore it reacts with another molecule of alkene. Again addition will be same. This H minus added to one carbon, BH added to another carbon. So what it become? CH3, CH2, B, CH2, CH3, and there is one hydrogen also be there. This is called ethyl diethyl borane. This diethyl borane again reacts with another molecule of alkene. Yes or no? Why? There is another hydrogen will be there. This hydrogen has H minus, B is a B plus. Therefore this H minus added to one carbon and B added to another carbon. So therefore what it becomes? Shall I write here? Okay, CH3, CH2, B, CH2, CH3, here CH2, CH3. What is this? Triethyl borane. So therefore now tell me, 3 moles of alkene reacts with 1 mole of diborane, it forms trialkyl borane. So trialkyl borane is the intermediate. Now trialkyl borane undergo further oxidation. It is undergo further oxidation in presence of H2O2 and NaOH. Basic medium. Right. Now this is, now here carbon, this boron bond will be broken. One OH add here, another OH add here. So therefore what it forms? CH3, CH2, OH. So there are how many? 3 molecule, no? One more OH here, OH here, another OH here, here is OH here. Therefore 3 moles of alcohol will be formed. Along with 3 moles of alcohol, BOH, OH, how many OH? BOH twice, which is equals to H3BO3, which is called boric acid. Have seen boric acid? ಎಲ್ಲರೂ ನೋಡಿರ್ತೀರಿ, ಅದೇಂತ ಗೊತ್ತಿರಲ್ಲ ಅಷ್ಟೇ. ಕ್ಯಾರಮ್ ಬೋರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ? ಕಾಯಿನ್ಸ್, ಕ್ಯಾರಮ್ ಬೋರ್ಡ್ ಪೌಡರ್, ಬೋರಿಕ್ ಆ್ಯಸಿಡ್. ಆಮೇಲೆ ಈವನ್ ಇನ್ ರೈಸ್, ಟು ಸ್ಟೋರ್ ದ ರೈಸ್ ಫಾರ್ ಲಾಂಗ್ ಟೈಮ್, powder will be added. That is a boric acid powder. So therefore, now tell me, this whole equation I will write in one step. CH2 double bond CH2, how many moles? 3 moles. Now tell me, there are two reagents. First one is BH3. This reaction takes place in presence of tetrahydrofuran. THF, tetrahydrofuran. Next, second reagent is oxidation, H2O2 in presence of NaOH. The product is what? CH3, 3 moles of ethyl alcohol. Okay. It is the method of preparation of alcohol. Now tell me, this reaction has very much important in preparation of alcohol. Why? One is alkene convert into alcohol, okay, by using diborane, right? Alkene converts into alcohol by using diborane. This is actually follows Markovnikov rule. Now whatever we added now, BH plus, addition of electrophile, nucleophile, it actually follows Markovnikov rule. It follows a Markovnikov rule, but the product which is come here, which is equals to anti-Markovnikov rule. Yeah, okay. This reaction, I repeat once again, listen carefully. This reaction follows, of course, Markovnikov rule, addition of electrophile, nucleophile, but addition of nucleophile is what? H negative. It follows a Markovnikov rule, the product which is comes in this reaction, which is equals to the anti-Markovnikov rule. The reason is, if you add water here, suppose alkene plus water, if you add water containing what? H plus plus OH minus. Therefore, we add H plus OH minus, but here we are adding H minus. Right. If you add H plus OH minus, you will get the product equal to Markovnikov rule. But instead of H plus, we are adding H minus. Right. That's what it goes opposite. Right. So here now negative part means H minus. H minus should be added where? The double bond carbon having where? Less number of hydrogen. For example, here writing product only important. CH3, CH double bond CH2, 1 B2H6, comma tetrahydrofuran. Even if they give B2H6, it is a diborane only. And second one, oxidation, H2O2 in presence of basic medium. So they expect product. What is the product? If it is according to Markovnikov rule, addition of water according to Markovnikov rule, tell me where the H plus should be added? H plus should be added first carbon. But is there H plus? Is there H plus? No, there is a H minus. H minus should be added on second carbon. Which is added first carbon? BH. Of course, BH2 no. And by breaking this bond only you will get OH no. Yes or no? It means, so remember like this, it follows of course Markovnikov rule, the product which is comes here which is equals to anti-Markovnikov rule. This okay, other important. Okay, next is what about carbocation? Is it carbocation forming in this reaction? No carbocation, no rearrangement. So therefore, one important note, this reaction takes place according to Markovnikov rule, but the product obtained, this reaction takes place according to Markovnikov rule, but the product obtained is equals to what? Anti-Markovnikov rule. Next, is there carbocation formed? No carbocation is formed and no rearrangement. So no carbocation formed and no rearrangement takes place. So therefore now you got the clarity how to write the product. For example, CH3, CH3 and reagents are same. You just write the product. Come on. Will you write the product? 1, 2. You just tell me where OH comes. First carbon, no? Here, where OH comes? First or second? The product which is comes equals to anti-Markovnikov rule. But actually takes place Markovnikov rule. Next. Here OH, no? Here. 1, 2. Ring expansion possible? No carbocation. Where is the question of ring expansion? Okay. So it is a second oxidation. Third one, oxidation with cold ion dilute KMnO4. Oxidation with cold ion dilute potassium permanganate. And better write here, oxidation with alkaline, cold and dilute alkaline KMnO4. So oxidation with cold ion dilute alkaline KMnO4. Tell me, what is the importance of alkaline cold and dilute KMnO4 is called what? Bayer's reagent, no? Alkaline cold and dilute KMnO4 is called Bayer's reagent. This Bayer's reagent can also be represented MnO4 minus OH minus, which is also be a Bayer's reagent. Right? Potassium permanganate in alkali medium, it should be cold and dilute, called Bayer's reagent. Now let's say first reaction. How does alkenes reacts with Bayer's reagent? Alkenes reacts with cold and dilute KMnO4 in presence of alkali medium. They form corresponding diols. That means two OH groups are added on two double bonded carbon. It becomes CH2 OH, CH2 OH, which is called 1,2 diol. So therefore, what is the statement? Alkenes reacts with Bayer's reagent to form 1,2 diols. Right? So alkenes reacts with Bayer's reagent, cold and dilute alkaline cheminophores form 1,2 diol. CH3, CH double bond, CH2, Bayer's reagent, write the product. Bayer's reagent. Here no carbocation, no rearrangement. Here is just add 2 OH group and 2 double bond carbon. That's it. So therefore here each double bonded carbon added with OH like this. So you just remove the pi bonds, that will be the product, right? But there is the important of this reaction. So what is the important of this reaction? See, important is, for example, if you take alkene with unsymmetrical carbon atom or unsymmetrical alkene, okay, or else you take, this is methyl here, methyl group here, okay, it is unsymmetrical alkene. This unsymmetrical alkene reacts with Bayer's reagent. So what is the Bayer's reagent? MnO4 minus in basic medium. Okay, then 2 OH groups are added, but 2 OH groups are added on same side of the double bond. It means you will get either 2 or above the plane, which is called cis, no? And cis trans, okay, of course, can be taken. Then if not, 2 OH groups are added even below the plane. So therefore this kind of addition is called what? Syn addition. It means alkenes reacts with Bayer's reagent. So 2 OH groups must be added on same side of the double bond, that is syn addition takes place. So therefore in presence of Bayer's reagent there is a syn addition. Tell me, where we have studied anti-addition? Alkene plus bromine. So alkene plus bromine or halogen is a anti-addition reaction. So 2 bromine atoms are added in opposite side of the double bond. Here same side of the double bond. You may get this or you may get this. There are 2 possibilities. It is a cis, it is also a cis. Okay. Then where this reaction is important? This reaction important particularly alkene having either cis or trans form. For example, let us take cis alkene. Alkene is a cis and Bayer's reagent. This Bayer's reagent is a syn addition. Tell me, in syn addition 2 OH groups are added same or 2 OH groups are added from the same side of the double bond. Now when 2 OH groups are added same side of the double bond, here already methyl groups are same side. Since methyl groups are same side, I will write the same side methyl group like this. Then again add OH same side, OH, you may get this, which is called what? Which component is? Meso compound. It means cis alkene, syn addition, meso compound. But in case of bromine, we studied opposite. Cis alkene, anti addition, very good, racemic mixture. Alkene cis, anti-addition, racemic mixture. Alkene is cis, syn addition, meso compound. Next, if alkene is a trans, and Bayer's reagent, of course Bayer's reagent is always a syn addition. Tell me. Now already methyl groups are opposite to the double bond, and we should add two OH groups are how? It should be same. Then now when you add two OH groups are same, then I'll bring two methyl groups are same now. When you bring two methyl groups are same, then two OH goes opposite. Like this. This is one product. Another one is, this OH may come right, it may come left also, no? That is also one possibility. So therefore, these are called what? Racemic mixture. So therefore here meso compound, racemic mixture, both are optically inactive. Meso is optically inactive due to internal compensation and plane of symmetry, and racemic mixture is optically inactive due to external compensation but not plane of symmetry. They do not have plane of symmetry. Next, like similar to bromine, Bayer's reagent also has one importance. See, what is the importance of bromine? We have studied bromine is used to identify the unsaturation. Very good. How do you identify unsaturation? Take alkene and alkyne and add bromine water or carbon tetrachlorobromine, bromine liquid. So bromine liquid has reddish brown color liquid. It is a reddish brown color liquid. When we add bromine to the alkene or alkyne and alkyne both will decolorize the reddish brown color of bromine. It means when bromine reacts with alkene and alkyne, it loses its color. That is called discharge, color discharge. Now same thing can be expected here in case of Bayer's reagent. How? First of all, what is the color of Bayer's reagent? Bayer's reagent is actually cold and dilute alkaline KMnO4, right? Cold and dilute. So what is the color of KMnO4? Purple color. If you take concentrated KMnO4, it is a purple color. But when you take dilute, it is a pink color. So therefore, the color of Bayer's reagent is a pink color substance. Okay. Therefore, now Bayer's reagent is used to identify the unsaturation. Bayer's reagent is used to identify the unsaturation. How? That is, alkenes and alkynes decolorize the pink color Bayer's reagent. So therefore, Bayer's reagent reacts with alkene and alkyne, it loses its pink color. So therefore, bromine as well as Bayer's reagent both have same property. Both are used to identify the alkene and alkyne. Can alkane decolorize the bromine water? No. Can alkane decolorize the Bayer's reagent? No. Only unsaturated compounds. Even it is a cycloalkenes possible, it must have double bond. Alkene, alkyne or any organic compound having double bonds, carbon carbon double bond, even carbon carbon triple bond, can give this unsaturation test. Okay, so this is the importance of Bayer's reagent. So therefore, in Bayer's reagent, 3 points are important. One, Bayer's reagent is a cold and dilute alkaline KMnO4 in basic medium, alkaline medium. Okay, next it is a alkene reacts with Bayer's reagent, it form diols, and moreover it is a syn addition. Addition of OH takes place same side, it is a syn addition, and it is used to identify the unsaturation. That's it. Next is oxidation with hot and concentrated KMnO4 in acidic medium. Oxidation with hot and concentrated KMnO4 acidic medium, or K2Cr2O7 acidic medium. Okay, see here, now it is a Bayer's reagent is a mild oxidizing agent. What is the meaning of mild oxidizing agent? Yeah, its oxidizing power is not very high, it is mild, but in presence of hot and concentrated KMnO4 acidic medium, and moreover, do you remember potassium permanganate acidic medium, there is a transfer of how many electron? 5 electron. Very good. Potassium permanganate in basic medium, alkaline medium, there is a transfer of only 1 electron. Acidic medium 5, neutral medium 3, in basic medium 1. There is a transfer of only 1 electron. Therefore, in alkaline medium, KMnO4 is a very weak oxidizing agent. That's what, due to weak oxidizing nature, so alkene get converts into diol. But tell me here, what is the possibility? Here possibility is alkene reacts with, or alkene undergo oxidation in presence of either potassium permanganate acidic medium or potassium dichromate acidic medium. Both are strong oxidizing agent. In presence of strong oxidizing agent, so it undergo complete carbon-carbon bond breaking. So C double bond C, bond will be broken completely. It may form carboxylic acid or it may form ketones. Therefore, alkenes undergo oxidation in presence of these two reagent, any one of this reagent. So where it forms either carboxylic acid. If carboxylic acid is not possible, it form ketones, but not aldehyde. Carboxylic acids or ketones. So therefore, what is the statement? Alkenes undergo oxidation alkenes undergo oxidation in presence of strong oxidizing agent like KMnO4 acidic medium or K2Cr2O7 acidic medium to form carboxylic acids over our ketone. Sometimes both also possible. Okay. Varun, are you okay? Huh? Varun ML. Okay. Right. Alkenes undergo oxidation in presence of KMnO4 acidic medium. Tell me. So writing product only important. Now how to write the product? It's very simple. You just break the carbon-carbon double bond. Okay. Then this carbon convert into carboxyl group. This carbon also converts into carboxyl group. Otherwise we can add 2 oxygen. Here also 2 oxygen. So therefore tell me CH3, let it be same. Then it is a C already H is there. Now it become what? COOH. In this oxidation 2 oxygens are added to each carbon. Now here H C double bond OH. This is a acetic acid. It is formic acid. But in fact this formic acid further undergo dissociation, decomposition, it gives CO2. So therefore you need to break the carbon-carbon double bond, then you should write the product. That is corresponding acids. One more. CH3, CH double bond, CH3. Come on, tell me now. Break the carbon-carbon double bond. This group converts into COH. It is also COH. How many moles of acetic acid? 2 moles of acetic acid. That's it. One more. Now tell me. It is undergo dissociation. Huh? Which one? This one? First one. It is alkene. No. Alkene plus strong oxidizing agent. You need to break the double bond. Complete agi carbon-carbon double bond break ಮಾಡಬೇಕು. Okay. When you break carbon-carbon double bond, we should add 2 oxygen. So add 2 oxygen to this carbon. Add 2 oxygen to this carbon. If it is 2 oxygen added, CH3 will be same. CH3, COOH. COOH. Here, CH2O, O2. It is a H, COOH, formic acid. It's very simple. You break the double bond and write the carboxyl groups. Here, break the double bond. You convert this is a carboxyl group. This is carboxyl group. First time. Here, now tell me. Here also you should convert carboxyl group. But this carbon is possible to convert carboxyl group? Now, can you tell me, can we add 2 oxygen here? You can add 1 oxygen, no. C double bond O, it is CH3. One more double bond like this. Baritira? Not possible. It means carboxylic acid is not possible. But here this carbon converts into carboxyl group. CH3 possible. Okay. Tell me. Huh? Ester? No. Complete bond break madbidi. Break the complete C double bond. C. Okay. One more oxygen can be added here, no? Ester is possible? Not. Ester bond does not form. Barala. No ester bond will be formed. Even though there are 2 oxygen, no, see, in order to form, see, listen here, in order to form ester, this bond has to be broken, no? This bond has to be broken. This bond has to be broken, 1 oxygen added here, it should be like this. So the breaking of, in already carbon-carbon double bond is breaking. So carbon, single bond carbon, this cannot be broken. That is not possible. Where another oxygen goes? Now how many oxygen required? We use in those oxygen only. So we don't bother about byproduct here. Particularly these kind of reactions, what are the byproduct? Many. These are the major product. So therefore, write one question. Write the product in the following. Bega. So write the products in the following oxidation reaction. 1. Just write the product. Which one? Strong. KMnO4 acidic medium, K2Cr2O7. This, yes. In D block element you have studied, no? They are strong, not mild. In alkaline medium, mild. Acidic medium, strong. Even electrochemistry we have studied SRP value. The SRP value of KMnO4, acidic medium, alkali medium, basic medium. Right, acidic medium is more, SRP. So therefore, in acidic medium, potassium permanganate, even potassium dichromate, both are strong oxidizing agent. In presence of strong oxidizing agent, you need to break the carbon-carbon double bond. Tell me, when you break carbon-carbon double bond, what is the product? And plus, it is also same, no? 2 moles of acetone. Yes or no? Next, here, break the 2 double bond. Right, it is a CH3, CH, CH3, COOH. And 1, 2 carbon means COOH, COH. Yes or no? Carbon 1, carbon 2. 2 are carboxylic group only. Now here 1, 2 moles. Tell me here. It is a CH3, C double bond O, CH3. Acetone. Next. Now here is ketone, right? It will be like this. But this is what? COH. this carbon COH, this carbon CO, and here 1 2 carbon means 2 carbon acid. Tell me here. Break the carbon carbon double bond. It is COH. This is COH. So number of carbon should be same. 1 2 3 4 5 6. Do you know 6 carbon dicarboxylic acid is called? In polymer we studied one important polymer, adipic acid. Very good. Adipic acid is a monomer of which polymer? Nylon 6,6. Yes or no? Hexamethylene diamine and adipic acid, nylon 6,6. Okay, now tell me here. Will you do it, David? ಮಾಡ್ತೀರಾ? See, if you have confusion, you count like this. This is 1 carbon, okay, or else 1 carbon, 2 carbon, 3 carbon. This is 1 carbon, 3 carbon, or what? Carboxylic groups. And here also 1 carbon, 2 carbon, 3 carbon. 1 carbon, 3 carbons are carboxyl group. It means 2 moles. Remaining you do it. Next, fourth one, catalytic oxidation of alkene. Fifth one, catalytic oxidation of alkene. See here, sometime the questions like this. By giving reactant, they expect product. By giving product, they expect reactant. For example, the molecular formula of hydrocarbon is C5H10 and it undergo oxidation with the molecular formula of alkene is C5H10 and it undergo oxidation with MnO4 minus H plus gives acetone and acetic acid. Acetone and acetic acid give the IUPAC name of alkene. Or what is the IUPAC name of alkene? Anybody? What is the IUPAC name of alkene? 2-methyl butadiene, right answer. So 2-methyl butadiene. ಗೊತ್ತಾಗಿಲ್ಲ ನಿಮ್ಗೆ ಇದು ಗೊತ್ತಾದರೆ ಇದು ಗೊತ್ತಾಗಿರಿ, ಇದು ಗೊತ್ತಾಗಿಲ್ಲ ಅಂದರೆ ಇದು ಕಂಪ್ಲೀಟ್ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ ಅರ್ಥ. ನೋಡಿ, alkene is C5H10 which is an oxidation gives one is a acetone and another one is acetic acid. Acetic acid I'll write like this. Okay, CS3 COOH. Tell me, what may be the alkene? Say actually it was alkene. On alkene there is a carbon-carbon double bond is broken. By breaking the carbon-carbon double bond, what is added? Oxygen, and here is 2 oxygen. Therefore you just remove the 3 oxygen and make a double bond between these 2 carbon. So that means it should be CH3 CH3 like this double bond, and this double bond carbon and this carbon, so both should be joined. So it is a C, and this H will be there, CH and CH3. If this is undergo oxidation, this bond is broken, no? O. So therefore, if the product given, you just remove the oxygens. By removing oxygen, you make a double bond. One more. Alkene oxidation, same oxidizing agent, gives product is gives the product what is the alkene, IUPAC name of alkene. Okay, so here both the alkene write together, and here carboxylic group. Okay, it is given like this, no? Yes or no? Then in these 2, what should be removed? 2 oxygen and make a double bond. So therefore it will be like this. It is a CH double bond and CH. That's it. You can cross check on oxidation of carbon-carbon double bond. Will you get this or not? Yes. So this kind of question can also be expected. Particularly, this is very, very important in ozonolysis. If you understand this, ozonolysis will be exactly similar, same concept. Okay, next is catalytic oxidation of alkene. Right, say here alkene undergo oxidation in presence of particularly silver metal, or silver is a catalyst. So alkene plus oxygen in presence of silver catalyst, it forms epoxide. What is epoxide? Oxygen is inserted in between where? Double bond. So therefore this double bond will be broken and oxygen comes in between through carbon, which is called epoxide. So therefore epoxide or are cyclic ethers. So alkene undergo oxidation in presence of silver catalyst to form cyclic ethers or epoxide. So it is very simple. You just remove the double bond, write cyclic ether in that position. Whatever may be the alkene, CH3, CH double bond CH2. Okay, it is a atmospheric oxygen and silver catalyst, or if it is a even cyclic alkene also same. If it is butene also, tell me. So here you just remove the one pi bond, right? Cyclic ether. Okay, no rearrangement, nothing. it forms just cyclic ether. But one point you remember, the same reaction can also be possible in presence of peracetic acid, which is called peracetic acid. What is acetic acid? CS3 COH, right? But CS3 COOH, it is called peroxy acetic acid. So therefore, the same reaction also possible in presence of peroxy acids. It is also called peracetic acid or peroxy acetic acid. Next is ozonolysis of alkene. Reductive ozonolysis. It is called ozonolysis of alkene. So this is very, very important. I think if you see on 5 model papers, at least in 3 model papers, this question will be there. Most important. In last year NEET exam, we got one question on this. So what is ozonolysis of alkene? See here, alkenes reacts with ozone O3. Alkenes reacts with ozone O3 to form, first it forms ozonide. What is ozonide? Carbon-carbon double bond will be broken. This double bond will be broken. By breaking double bond, it forms an intermediate where 3 oxygens are inserted. There are 3 oxygen atoms are inserted between 2 double bonds. In place of 2 double bonds, like this. You should not write again double bond here. You see the valency. Valency is satisfied. Valency of carbon is 4. Here also 4, which is called ozonide, which is an intermediate. Therefore, alkenes reacts with ozone to form ozonide. This ozonide undergo further reduction. That's what it is called, reductive ozonolysis. It undergo reduction in presence of zinc and water. So this reagent is important. Zinc water. If you take zinc H2O2, that will be different. That is called oxidative ozonolysis. We will study later. Zinc and water, which is called reductive ozonolysis. In presence of zinc and water, so here all the oxygen bonds are broken like this. When all oxygen bonds are broken, tell me what is the product? What may be the product? Tell me here. CH3 CHO. What is this? Acetaldehyde. Next CH2 and this is O. What is this? Formaldehyde. It means you will get either aldehydes or ketones. So therefore, what is the statement? Alkenes reacts with ozone to form ozonide, which is undergo reduction in presence of zinc and water to form aldehydes and ketone, not carboxylic acid. There we have studied carboxylic acid in case alkene plus oxidation. Here you will get either aldehyde or ketones only. So therefore, statement is important. Alkenes reacts with ozone to form ozonide, which is undergo reduction in presence of zinc water. Important. In presence of zinc water to form aldehydes or ketones, or sometimes both also, both aldehyde ketone also be possible. So therefore alkene get converts into either aldehyde or ketone or both aldehyde ketone. Then how to write product? Now this is the actual reaction. Then writing product in simple way also important. CH3 CH double bond CH2. One question will be like this. First is ozone, then second reagent is zinc water. Tell me. Now here in presence of this reagent, you just break the carbon-carbon double bond and add one oxygen here, not two oxygen. In oxidation we added two oxygen. Here is add one oxygen. Okay. So therefore, tell me, it becomes what? CH3 C double bond OH. It is become H C double bond OH. Same or not? Very simple. Break the double bond, add oxygen for each carbon. Right. Next. Written question. Complete the following reactions. Complete the following reactions. 1. Both are same, no? Tell me. So what is the product here? Bega. So break the double bond. You break the double bond. In place of double bond O, double bond O. It is a acetaldehyde, acetone. Okay. See here also. Break the double bond. 2 moles of acetone. Now suppose product is given. So in product is given, again you should write like this. Remove the O2 and product will be alkene, right? Next here. It is a 1, 2. This carbon become CHO, right? Now here, it is a CHO, CHO. It means CHO, CHO. It is called glyoxal. Next, this is CHO, this is CH3. It is nothing but 2 moles. Yes or no? Here, it is acetone. Now tell me, here this is CHO. It is a one bond is there. That's what it is. What? C double bond O. This is CH3. CH3 C double bond O. No. Again it is CH3. CH3. No, not 2 more. That is different. CH3 C double bond O. CH3. Okay, you do remaining all, but this is these two important. We'll study these two. Will get in a benzene topic. Benzene reacts with ozone, zinc, water. Ozonolysis. What is the product? Benzene has 3 pi bonds. No, tell me here. This is a CHO, CHO. Next, it is a CHO, CHO. CHO, CHO, how many? 3 moles. So 3 moles of glyoxal will be formed. Now this is the confirmation for the presence of 3 double bonds. Benzene containing 3 double bond, that is in alternate positions, because we got 3 glyoxal. Here tell me. It is a CHO, C double bond O. So it is a CHO, C double bond O, CH3. Next, CHO, C double bond O. CHO, C double bond O. How many moles? 3 moles. Okay, remaining all you can. Okay, so therefore, what is the importance of this reaction? This reaction is used to identify the, This reaction is used to identify the position of double bond. This reaction is used to identify the position of double bond in alkene. Position of double bond in alkene. For example, position of double bond in alkene. Write down question. The reductive ozonolysis of alkene gives 2-methyl butanol and 2-methyl propanol. 2-methyl butanol, 2-methyl propanol. What is the position of double bond, or what is IUPAC name of alkene? So IUPAC name gives nothing but position of double bond. So tell me, what is the position of double bond or IUPAC name of alkene? So first write 2-methyl butanol. No, butanol is 4 carbon, 2-methyl, this is a butanol, 1, 2, 2-methyl Okay, sorry, aldehyde. Next, one more is 2-methyl propanol. It is a propanol is how many carbon? 3 carbon, 1 2-methyl propanol. Then what to do? In 2 carbonyl group, remove the oxygen. So therefore, I'll write like this. Okay, hydrogen will be there, and this is C double bond O H, this carbon, and CH3C. Remove the oxygen. Then tell me now. One, two, three. 1 2 3. So the position of double bond is 1 2 3 4 5 6. 4 ಇದೆಯಲ್ಲಿ 1 more ಇದೆಯಾ? ಓಕೆ. ದೆನ್ ನಂಬರಿಂಗ್ 1 2 3 ಈ ಕಡೆ ಬರುತ್ತೆ. ಸೊ ಐ ಪ್ಯಾಕ್ ನೀವು ಬರಿಬೋದು ತಾನೆ? ಓಕೆ.